Welcome to Math Class Today, where we are going to be working with unit rates again. This time we're going to be working with distance and measurement, but it's largely the same, so it's some good practice of the things we've been working on in our last couple of lessons. So our learning target today is still to be able to describe a unit rate and solve unit rate problems, but today we're going to be doing it involving distance. Let's get started. Justin is riding his bike at 15 miles per hour. If he traveled for 4 hours at the same speed, how many miles did he travel after the 4 hours? So, like we talked about in our last lesson, it's important that you look at the information you are given. Are you given the unit rate, or are you being asked to find the unit rate? Because that will make a difference in whether you're dividing to find the unit rate or multiplying to use the unit rate. So in this case, you were given 15 miles per hour. That is the unit rate. So we're not finding the unit rate, but we are going to use it in order to find how far he will travel in 4 hours. So that means we're going to scale up by 4. So we need to multiply both the top and the bottom by 4. And 15 times 4 is 60. So how many miles did he travel after 4 hours? He traveled 60 miles. So again, in that one, we were not finding a unit rate. We were using the unit rate to find some more information. Lily can run 3 miles in 18 minutes. If she ran 1 hour and 12 minutes, how many miles did she run? So the information we're given is 3 miles in 18 minutes. That is not a unit rate. It is just a rate. So we have 18 minutes for 3 miles. So that means that she ran 6 minutes for 1 mile. 6 minutes per mile. We want to know if she ran 1 hour and 12 minutes. So that is 72 minutes. I'm going to convert that to minutes. I don't want to be dealing with hours because I already have minutes in my problem. So 1 hour is 60 minutes and 12 more is 72. So that would be 72 minutes. And I want to know how many miles she ran. So I'm going to scale up to get from 6 minutes to 72 minutes. I need to times by 12. So I'm going to do that same thing here. And 1 mile times 12 is 12 miles. So it looks like if she ran 1 hour and 12 minutes, how many miles did she run? She ran 12 miles in 1 hour and 12 minutes. Again, we wanted to change our units from hours back to minutes, so we had that skill that we needed to work on. You didn't actually need to find the unit rate. You could have gone directly from 18 to 72 if you knew what to scale up by. So that was an extra step, but it's an extra step that might have made it easier for you to deal with. Okay, a jet flies 2,000 miles in 4 hours. What is the unit rate? And how far would the jet travel in 7 hours? So the information we're given is not a unit rate. The question asks us to find the unit rate and then use that unit rate. Go ahead and pause your video. We've done lots of problems like this, so go ahead and pause it and see if you can figure it out on your own, and then check the answer. Okay, so 2,000 miles in 4 hours would be 500 miles per hour. There's the unit rate. So there's the first part of our answer. The jet is traveling 500 miles per hour. Now, let's go ahead and find out how far the jet would travel in 7 hours. So we're going to scale up by 7. So 500 times 7 is 3,500. So the jet would travel 3,500 miles in 7 hours. Ellie and her family are going on a trip to St. George. If St. George is 375 miles away, how many hours will it take them if they are traveling at a constant speed of 75 miles per hour? Okay, so you're given 2 bits of information there. We know that they're traveling 375 total miles, and we know they're traveling at a rate of 75 miles per hour. So we're already given the unit rate. So we're not trying to find that. All we're doing is trying to use that to find out how many hours it will take them to travel 375 miles. Okay, so I need to figure out what I'm scaling up by. 75 times what is going to give me 375 miles. So you could use division. You could do 375 divided by 75, work backwards to figure that out. So we're scaling up by 5. So it will take them 5 hours to get to St. George, traveling at a rate of 75 miles per hour. So the question said, how many hours will it take them? So my answer is 5 hours. Brody flies helicopters and does tours around Zion National Park. Each tour is 75 miles long. If Brody can complete the tour in 3 hours, how many miles does he cover each hour? So we're given 75 miles in 3 hours. We're looking for how many miles he covers each hour. So we're looking for the unit rate. So 75 miles in 3 hours, so 75 divided by 3 is 25 miles per hour. So there's the first part of our question. How many miles does he cover each hour? He covers 25 miles. How many tours would Brody have done if he traveled 375 miles in one day? All right, so each tour takes him 3 hours. And each tour is 75 miles long. So I'm going to go back and use that. One tour is 75 miles. How many tours if he's done 375 miles? So what am I going to scale that up by? So 75 miles equals one tour. I'm going to kind of change that down there. So again, I scale up by 5. So if I times by 5 and times by 5, it looks like if he's done 375 miles, he will have done 5 tours. Now, the reason I changed that was because I wasn't looking for if he's done 375 miles, how many hours has he been doing it? It asked me how many tours would he have done. So I knew that 75 miles was equal to one tour. So that's why I changed my rate there and the 2 units I was using. A skydiver falls 144 feet in 3 seconds. How does he fall? How far does he fall per second? So I'm looking for the unit rate. Go ahead and pause this, find it on your own, and then check your answer. So 144 feet in 3 seconds. How far per second? So I'm trying to find 1 second. So I'm just going to do 144 divided by 3, which gives me 48. So the skydiver is falling at a rate of 48 feet per second. Steve drives 78 miles on 3 gallons of gas. Find the miles per gallon. So I'm trying to find the unit rate. So pause this, go ahead and find it, check your answer. Okay, 78 miles on 3 gallons. I'm trying to find the miles per 1 gallon. So I'm just going to do 78 divided by 3, and that is 26. Whoops, not 28. 26 miles per gallon. That's how fast how many miles per gallon he's going to get. Okay, Marla walks 12 miles in 3 hours. How many miles does she walk per hour? If she walked at the same pace, how long would it take her to walk 36 miles? So we have 2 things that we're trying to find here. The unit rate is 1, how many miles per hour? And then number 2, we're going to use that unit rate to figure out if she walked 36 miles, how long it would take her. Pause it, try it on your own, and then check your answer. Okay, 12 miles in 3 hours is a rate of 4 miles per hour. So there's the first part of the question. How many miles does she walk per hour? She walks 4 miles per hour. So at that rate, if she walked 36 miles, how many hours would it take her? So what am I using to scale up from 4 to 36? I'm scaling that up by 9. So it would take her 9 hours to walk 36 miles. So there's your answer. All right, so we're going to do a couple of extension problems here. So this is asking us how tall is the building. So we're going to set up these two structures are in a ratio to each other. So we're going to set up the height of the length to the length and the height to the height. So building number 1 is h feet. And we're going to set that up as the ratio, the height of the bookcase is 50 feet. So height to height. And then we're going to set up the length to length. So the first building, again, was 50 feet. And the bookcase is 12 and a half feet. Okay, so we've got to figure out what ratio, what we're scaling it up by. These two ratios are equivalent. So we've got to figure out from 50 feet to 12 and a half feet what's going on. But since I have a variable in the first one, I'm really going to look at my second one. So to get from 12 and a half to 50 feet, I am scaling up by 4. So 50 divided by 12 and a half is 4. So I'm going to scale up by 4 here. So 50 times 4 is 200. So that building is 200. H would equal 200 feet. So again, I set up my ratio. This first ratio is the height of the first building to the height of the bookcase. And my second ratio is the length of the shadow of the first building to the length of the shadow of the bookcase. And then I just used my equivalent ratios the same way. I figure out what I'm scaling up or scaling down by, and then make sure I do that to both problems. Okay, the second extension problem is very similar, but it's with a flagpole. So we're going to set up the height of the first flagpole to the height of the second flagpole. And then the shadow of the first flagpole to the shadow of the second flagpole. Okay, you could also set this up as height to height. Oh, that's what I did. Sorry, as height to shadow and height to shadow. You could do that as well, so long as it was the same. All right, so to get from 2 to 7, that's a little bit trickier, but it's not a whole number, but if you did 7 divided by 2, you can figure out what you're scaling up by, and it is 3.5. So you would want to do the same thing there and do 6 times 3.5, and you would get 21. So the height of that second flagpole is 21 feet. All right, that should set you up to be successful on your assignment today using unit rates to find distance and measurement. Again, be very careful when you read the problems and make sure you know if you're finding the unit rate or whether you already have it and you just need to use it. Good luck.